The next transformation we're going to look at is something called enlargement. Enlargement is basically making a shape bigger, as you'd expect, or making it smaller, and a lot of people forget that. It needs two bits of information. The first is scale factor. The scale factor is the number of times we're going to increase it. So if I had a scale factor of 2, it's going to get twice as big. However, if I've got a fraction scale factor of half, then it's going to get smaller. We also need the centre, a point at which to start our enlargement from. The point being that we don't just increase the size of the shape, we increase space around it. And we can see that in a second. So here we've got a shape. I apologise if any lines aren't quite on the points. Unfortunately, the software of the computer doesn't allow it. But here we've got a shape, a parallelogram, that we're going to increase by a scale factor of 2 around the origin as the centre. And the origin is where the y and the x-axis meet at 0, 0. All I'm going to do is count the number of squares from the origin across to where the x lines up with one of the corners of the shape I'm enlarging. So if you look at this point by here, and I could have used any of the other corners as well, at this point, if I go straight down, I want to count to that third square on the x-axis. So it's 3 right, and if I multiply that by 2 because of the scale factor 2, I've got to start the next shape 6 right from the centre instead. Next, I've got to count 3 up to get to the corner of the parallelogram. Again, if I multiply that by 2, I've actually got to go 6 up. So the original count was 3 across and 3 up. I've multiplied both those by 2 because the scale factor is 2, which means I go 6 across to the right and 6 up. Now I do the same for the shape. So it's 2 to the right to the next corner. 2 times 2 gives me 4, so I go 4 to the right for the corner up here. It's 1 across and 2 up for the next corner, so it's going to be 2 across and 4 up for the next corner. Again, I went off the graph by here by mistake. And now from that I can draw my parallelogram in. Sometimes once you've done a couple of points that you can see where all the others will join up, sometimes it's better just to go counting all the way around. So I could have done 2 to the left turns into 4 to the left and come back 4, and then 2 down and 1 to the left becomes 4 down and 2 to the left, so 4 down and 2 to the left, but I've just simply drawn the parallelogram in this case. And there we've enlarged that parallelogram from a scale factor of 2 around the origin. Here we've got another shape then across, and we're going to enlarge it by a scale factor of a half around the centre of -2, 1. So the first job I'm going to do is go across to where x is -2 and up to where y is 1. Should point out as well, on your graphs in exams you should have the y's, the numbers on the y as well, and the x, not just blank ones as in this example Cartesian graph. So the centre of my enlargement is this point by here, -2, 1. And that is the point that I'm going to start counting on. So I'm going to go straight down to this point here. It's straight down, so it's easy to get to. So that goes 4 down. My scale factor was a half, so 4 times a half is 2. I'm only going to go 2 down instead. Then on the original, we went 1 to the left. Well, 1 times a half is a half, so I'm going to go half across, 1 up. 1 times a half gives me a half, so we go half up. 2 across, 2 times a half is 1, so we go 1 across. And we're going to continue this process, looking at how far each measurement has come across on the original shape and multiplying them by a half to draw them on the shape we are creating. And as you can see, this is now an enlargement of a half from the center minus 2, 1, where the shape has got twice as small instead of large. So that's how we do enlargements. We need a scale factor, we need a center of origin, we look for the corner points on the particular shape, count across to how many squares we need to go to get there, and then multiply those by the scale factor to come up with a new amount that we go across or up or left and so on.